Hi Math 8 students, this is Mr. Kuzinski. I've got the solutions for you to our first paper version of our checkup from Unit 8-1.1. Hopefully this will help you with your corrections tonight. Alright, first question, does this graph show a linear or nonlinear relationship? Okay, the only thing we're really looking for here, folks, is to say that it's linear and to say that we know it's linear because the points are falling in a straight line. The points fall in a straight line, which indicates a constant rate of change. You don't really have to get any more specific than that. Next up, does this graph show a linear or nonlinear relationship? Well, the bottom line is it's not linear. It's nonlinear, and the points form a curve, but more importantly, that indicates that the rate of change is not constant. Okay, so any curve means it's not straight. So that's really all I just say is that they don't form a straight line. Nonlinear, the points form a curve which indicates the rate of change is not constant. So, I guess bottom line when you're looking at a graph, do the points form a straight line or do they not form a straight line? That's all you have to talk about, guys. Don't get into the numbers too much. Now, we're forced to deal with the numbers. Does this table show a linear or nonlinear relationship? Well, you can see over here that, I assume these are the x values. They're going up by a constant rate of 1. And over here with the y values, the outputs, they are increasing by 3. So every time x goes up by 1, y goes up by 3. That makes it linear. As the inputs increase by 1, the outputs increase by 3. There is a constant rate of change. There is a constant rate of change here. Okay, well, on number 4, it says make a table that shows a nonlinear relationship and explain how you chose your numbers. Well, you can see here that I've put some numbers in already. Yours could be completely different, but I went ahead and showed that my inputs are going up by 1, but then I made sure that there was no constant rate of change for my outputs. Very, very close. You know, I made it basically go down by about 10 every single time, but this one value is just a little bit off here. This 29 should be a 30 if it were to be perfectly linear. So, explaining, although the first column goes up by 1, the second column does not go down by a constant rate. This is somewhat linear, but not perfectly linear. A lot of people on these two, and even on 1 and 2, talked about one being factors of the other, like 3 times 3 is 9, and 4 times 3 is 12, and 5 times 3 is 15. That will guarantee that the relationship is linear, but then on the other side, just because that isn't true doesn't guarantee that it's not linear, which is a very tough thing, but I'll try to explain in class. So if these are always divisible by these, if y is always divisible by x, that does guarantee it's linear, but just because that's not true doesn't mean it's not linear. Alright, we got a party room at the miniature golf course. It's decorated with golf ball patterns like the ones below. Complete the table. So I guess, you know, some people would probably notice without even looking at these patterns here, just by looking at the table, that we see an increase of 2 and then an increase of 3. So they would think probably that it's going to be an increase of 4 and then 5 and then 6 and then 7 and then 8. If we actually, make the next step 4, we're going to have to add a golf ball here, a golf ball here, a golf ball here, and a golf ball here. So we are going to have to add 4. And then if we do step 5, we're going to have to add a golf ball here, 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 and here. So, yep, we're adding 5. So that is the pattern. We want to increase by 4, 5, 6, 7, 8. So 6 plus 4 is 10. 10 plus 5 is 15. 15 plus 6 is 21. 21 plus 7 is 28. And 28 plus 8 is 36. So those 5 numbers are what I was looking for. And lastly, using the following table, make a scatter plot that represents a different golf ball pattern. Is this linear or non-linear? Okay, so all I have to do is plot these points. So I've done that under here. So 1, 4, over 1, up 4, 2, 10, 3 and 16, 4 and 22. You can see that these do form a straight line, meaning it is linear. You can also see here that the constant rate of change is 6. 4 plus 6 is 10. 10 plus 6 is 16. 16 plus 6 is 22, and so on. So this is linear because the constant rate of change is not 4, but 6 golf balls, and this forms a straight line on the graph. Okay, that's all I've got for you. Hopefully this helps as you do your corrections, and I'll see you soon. Have a great night.